Okay, I think it is given live. I think Vasant, you can lower your hand. Okay, sir. I think we are on. Okay, we are on job. Okay, so we'll start, sir. You
Yeah, we
ready,
can
sir?
start. Yeah.
Okay, sir. So very good evening to all present here for all the intern from various engineering colleges, especially the chemical engineering department. The finally students from 5 different colleges. So I think yesterday I think we started with the first session from Chennai Petroleum Corporation Limited from B. Sriram. So today we are entering into our Nagarajan sir, who is very dynamic and always supports for the students' knowledge, wisdom. So he is delivering so many lectures for many society, and he is also chairman of IICC Chennai Regional Center, and he is a DGM of Petrofac. Anyhow, a much more detailed profile will be like read by our Dr. Subhashri ma'am. Very like his session is going to be like almost like a very highlighted and a keynote we can say, because he prepare and he's brings up so much of utilization time, especially for the chemical engineering design and much more, because his total career was contributed on the design. So he was there in Petrofac, and then so much of design company. He has traveled across the world. So kind enough, sir, to join today evening. I hope, I think because the students of final year or something, they feel some um, we can say like a sickness because of COVID. They don't know like what's next going to happen. But definitely, I think as you are all experienced, you can always like mentor them and say and boost their opportunity which is going to come in the near world. Thank you so much. Let me welcome our Subhashri ma'am to read our sir profile.
Yeah, thank you, sir. Good evening, everyone. I'm happy to welcome our speaker today, Mr. N. Nagarajan, Technical Director, iFluids Engineering, Chairman, IACHE CRC, who is a professional process engineer associated with reputed engineering consultancy organizations in India and overseas countries such as USA, UK, Germany, Indonesia, and UAE for the past
Ma'am, your
36
voice
plus
is
years.
quite low. Can you keep your mic nearby?
Yeah. He started his career with the major fertilizer company of India, the Indian Farmers Fertilizers Cooperative Limited, as trainer in ammonia urea plants. His subsequent associations include IDEA, a reputed organization based in Chennai, John Brown Technologies in and then to Lloyd's Registered Shipping at Aberdeen, UK, and specialized in conducting design appraisals for offshore process systems. He has been accredited with Surveyor Level B authorization to conduct independent design appraisals leading to certification process by LRS. His overseas career includes PT Sempak Indonesia and PT Technic Indonesia. He held head of process department position and was lead process engineer for many offshore oil and gas projects in Indonesia. He finally saw the global EPC major Petrofac Engineering Services India Private Limited as head of process discipline and supported many international projects of Petrofac International Limited, Sharjah, before retiring in early 2016. He is a certified associate trainer for process engineering subjects and has been providing training services to Petrofac Training Academy at Sharjah office. So we are happy to welcome you, sir.
Okay. Thank you, Dr. Subhashri, madam. And I'm very happy to be a presenter to the chemical engineering students from 5 engineering colleges. It's always my pleasure to be among the young students, where I feel young when I am among the students, and also it gives me a lot of opportunity to share my knowledge and experience to the young engineers and also to guide them for a proper career path. So first of all, my thanks to the Institution of Engineers India and the Ersago Solutions for organizing this series of lectures on technical topics. And my heartfelt thanks to Mr. Gokul, who is our secretary, honorary secretary of Indian Institute of Chemical Engineers, Chennai Regional Center. And notably today, 2nd November, is the Founders Day for Indian Institute of Chemical Engineers. The founder of Indian Institute of Chemical Engineers, Dr. H.L. Rai, was born in 1889 in the erstwhile, presently it is in Bangladesh, and he was the one who founded this organization to serve the chemical engineering professionals as well as students. Person with a great vision, and it is paying its fruits to the youngsters of today. So let us remember, thankfully, Dr. H.L. Rai, who started this very prestigious institution, in Indian Institute of Chemical Engineers. So my hearty welcome to all the final year students of the 5 colleges, and it's my pleasure to share my knowledge and experience. Before that, as our secretary, Mr. Gokul, pointed out that present COVID situation, really students are perplexed, or they need some guidance how to go about it, and how the government is tackling this issue. I think the exams may be online, but I think November 16th onwards, there is a communication from the state government that colleges are going to be open. So in that case, my request to all the students is be very safe and follow all the safety precautions given by the government as well as the medical experts, and at the same time spend your time very usefully. So as Dr. Subhashri Madam explained, I have been design engineering person all along for the last 40 years. So I am a postgraduate in chemical engineering from Annamalai University in the year 1979. So let us go into the topic today. And in most of my lectures to the students, I used to tell what are the different career paths available for them. One such career path is the design and engineering part. There are a number of design and engineering organizations in India itself. When I started my career, there was only one major engineering consultancy organization in India. It was Engineers India Limited. Most of you might be knowing. It is located in Delhi. So it was a very, very big organization. About 4,000 employees were there when I joined the company in 1980, and it offers a variety of specializations. And the chemical engineers are usually called the process engineers. And we are the originators of the process technology, and then the designers of the process facilities. So we take pride in being the front runners and pioneers in the process plant design. So we were all going to be such prestigious engineers of tomorrow. So this is one important field in the chemical engineering area. So I'll start with the presentation. Today I am going to give an introduction to process engineering design. First of all, my hearty welcome to all the final year students and other academic personalities and respected staff members. So we all know we have been studying for the last, you were studying for 4 years the engineering subjects, and finally maybe last 2 years we may be studying the core chemical engineering subjects. So all the theory and principles remain the same. I will explain how these principles are applied in the actual industrial environment. So that is all about the process engineering design. So we'll go into the presentation. So the technology development, people used to say technology. In our times in the university, we had the engineering department was called engineering and technology. So it was headed by a dean, the dean for engineering and technology. Chemical department, chemical engineering department was usually called as technology department. So our HOD will be called as Head of the Department of Technology, HDT. And other engineering disciplines, when I studied only three more, apart from chemical engineering, we had mechanical, electrical, and civil. Only four engineering streams were there. Now you have a lot of diversified fields in engineering. It has expanded as the time progresses. The engineering field has developed and it has reached whatever it is today, this level. So what do you mean by technology? So people quite often use the term technology. In our process engineering terms, technology is nothing but the conversion of naturally available raw materials into products used in our day-to-day life. So very simple examples are sugar from sugar cane. And similarly, liquefied petroleum gas, LPG, which is the cooking gas used in our household. Kerosene is again a fuel. And petrol, diesel, these are all the fuels for automobiles. These are all derived from crude oil. So how to separate the crude oil into so many products is called the technology. Similarly, we make cement from the clay, limestone, coal, etc. These are some simple examples I have given you. This conversion process is called technology. So the technology is not developed overnight. It takes a lot of research. So you must have come across many scientists in your textbooks who have invented so many things and which are all the reality today. So it takes significant research activities to develop the technology. And in technology, we have two types. One is called open art. Another one is called licensed technologies. Open art is the technology which has been in use for many years, hundreds of years, like distillation to manufacture alcohol from the uh, starch-bearing materials. So that is open art, and it is available. The details of the technology are available in the open literature, and that is why it is called open art. You don't need to depend on a licensor who has invented the technology. Whereas there are licensed technologies which are developed by major research organizations in the world, and they offer their technology for a price. You have to pay money for the technology. They give the technology and design of the plant, and you have to pay upfront some licensing fee. Then you have to keep on paying them for some time, what is called the royalty on their product. So per ton of product, you have to pay so much. These are all the commercial terms for the licensed technologies. So just briefly about the chemical engineering operations, which since you are in the final year, most of you have already come across these subjects. We have two major topics in the chemical engineering operations. One is called the unit operations. The second one is the unit processes. Unit operations is mainly the physical changes. That means the materials we use in these unit operations, they don't undergo any structural change or no change in their formula, chemical formula. But the state changes, maybe the solid to liquid or liquid to gas, only change of state happens. So in that, under unit operations, you have three distinct transfer operations. One is called the momentum transfer. You all know we have to carry forward the various materials used in the processing, and how to move these fluids is about the momentum transfer. It may be movement of liquids or movement of gases or even movement of solids. But the term I am using here, driving force pressure differential, is basically for transfer of liquids and gases and vapors. Solids, they are always conveyed in a conveyor or some mechanical means. They are not under any pressure and all. So it's only the energy, mechanical energy spent in carrying the solids through the conveying mediums. So here we are talking about driving force pressure differential is for the liquids, vapors and gases. Second important transfer process is the heat transfer. Subsequent slides, I will explain more the use of these transfer operations. Heat transfer is nothing but transfer of energy. Okay, we have to apply energy to achieve certain processes, like boiling water. Even at a household, you put the water on the gas stove and switch on the gas. Then the water slowly heats up and boils and becomes a vapor slowly. So the temperature difference is the driving force here, because the temperature flows from a higher temperature to lower temperature. Similarly, pressure differential, higher pressure source to a lower pressure source. Mass transfer is another important unit operation which deals with the transfer of components between the phases, between liquid and vapor phase. Okay. Here, driving force is the concentration differential. That is, some components may be more in liquid phase and some may be more in the vapor phase. There is a mutual exchange of components between the phases. That driving force is the concentration differential. And unit processes, on the other hand, is a chemical change. That means the materials which are interacting or reacting undergo chemical change. The structure of the compound changes, their molecular formula changes, their properties changes. It's totally a new one compared to the starting materials. So these are called the reactions and synthesis. The reactions, as you all know, may be catalytic or non-catalytic. Some reactions happen without any catalyst. They are non-catalytic. Some reactions happen with the use of a catalyst. So two types of synthesis are there. So feed preparation, these are the major things, typical process plant operations. Typical process plant operations is feed preparation, reaction. In a process plant to run successfully and produce the products, we need support systems like utilities, offsites, and logistics. Utilities, very simple example is in the household we use electricity for running all the appliances, and gas stove we use the gas for cooking, and then water system, water storage tank, and water sumps, all those things. These are all the support systems which make our life easy. So in the chemical plant also you need such utilities like steam, water, nitrogen, all those things are utilized. These are called the utility plants. Offsites and logistics. Offsites is any process plant needs raw materials, and the supply of raw materials may be regular or sometimes it may be irregular. In that case, you need to store the raw materials. That is called the offsites and logistics. Logistics is to bring the raw materials to the process plant and to take out the produced products to the consumers. So I'm just giving you a block flow diagram, which simply explains whatever I showed in the earlier diagram. See, we have raw materials, and many times raw material may not be in the proper form to subject it to the required change. So we prepare the feed, and for that we need some energy. Similarly, then the prepared feed material or raw material undergoes a reaction, which may need a catalyst. If required catalyst is added, again we need to add energy. The reaction products come out with a lot of energy. So we first recover the energy, cool the products, and then from the energy we make steam, and then from steam you can make power. So then the reactor effluent goes for product separation. So this is where your mass transfer operations come. We separate the products and we get the final product. Sometimes we may get additional products which are called byproducts. Okay. So you can see every stage there is energy, either energy is consumed or you supply energy. Sometimes if it is an exothermic reaction, you may remove the heat from the reaction to make the reaction proceed in the forward direction. So this is called a typical block flow diagram, which shows the process plant operation in simple blocks. And the diagram shows the sequence of processing. Okay. Now we talk about the hydrocarbon sector. We commonly call this a hydrocarbon sector, which is a very big industrial sector, and which is again divided into three sections. One is oil and gas projects. You all know crude oil and natural gas are available from the earth. A lot of exploratory work is being done. There are companies which do the oil exploration, gas exploration, and they bring out this wonderful raw material. This is called black gold. Many of you know crude oil is called the black gold. So it fetches so much of money. So then the oil and gas, once they are extracted from the reservoirs underneath the earth, they are subjected to some separation operations. We separate the oil, gas, and then feed them to the downstream units. So the oil and gas projects are called upstream. Then from this, the gas goes for energy sector. You can make electricity by burning the gas in the gas turbines, or you can use the natural gas for making a lot of chemicals, petrochemicals, fertilizers, etc. Then the crude oil goes to the refinery where a lot of value is added. We may ask crude oil as such, what is the value? Crude oil as such has a very low fuel value. That's all. If you use crude oil as such, it will be a very low grade fuel. But if you refine it and segregate it into various products, they get value addition. And the value of crude oil is many times enhanced. So that operation is done in the refineries. These are called midstream. Okay. Then the refinery feeds raw materials to the petrochemicals, mainly naphtha or even gas from this refinery. They are all used to make a lot of petrochemicals. So these are called downstream. Petrochemicals mainly they crack the naphtha into lighter fractions like ethylene and propylene. So ethylene and propylene are called the building blocks of petrochemical industry. Once you have ethylene and propylene, you can make a host of petrochemical products. In the textbooks, you might have seen a lot of branches coming out of this ethylene and propylene. So many products can be manufactured. Then apart from that, fertilizers and chemicals are the other process industries. They are not necessarily from hydrocarbon. They may not be hydrocarbon dependent. There may be inorganic chemicals which are also again from metals extracted from the earth. Fertilizers can be used to make. So the next diagram is also a block flow diagram, overall block flow diagram of the oil and gas industry. I have not shown the chemicals and fertilizers here. So whatever I explained there, oil from the wells, oil and gas, they are separated. Gas goes through a number of purification steps in the gas plant. Then purified natural gas goes for either you liquefy and send it as the liquefied natural gas, or through pipeline you send it to natural gas consumers, maybe the power plants or fertilizer plants. And the impurities like hydrogen sulfide, carbon dioxide, etc. will be removed in this gas plant. They are called the acid gas. They are treated. If it is H2S rich gas, you can separate the H2S from the natural gas and then make pure sulfur from the H2S. Why we liquefy the natural gas? So you may be wondering what is the purpose. You all know carrying gas requires a lot of efforts. Means you have to put long pipes and transport the gas distances, and pipelines are very expensive if you put them for long distances and all. Another way of transporting natural gas to consumers is liquefying the gas. It reduces in the proportion of 600:1. That is 600 volumes of natural gas when liquefied becomes 1 cubic meter. So you can really understand and appreciate the reason for liquefying the natural gas. Then the liquefied natural gas can be transported through large ships, large cargo ships. So that is on the gas part. Then oil is processed, and any water associated with the oil is removed and treated and disposed. Crude oil transported through railways, okay, or ships, large ships. Oil refinery. From oil refinery, we get a number of products, light ends, which are called fuel gas, chemical feedstock, that is naphtha and all, LPG. You all know gasoline is used as aircraft fuel. Then you have household fuel. Then you have diesel for automobiles, fuel oil, lubricating oil. The final thing is bitumen, which is also called asphalt, used for road laying and all. Okay. So now we get into the process engineering design activities. What is the function of the process engineering? Consulting and companies, engineering companies. So how the process engineering design is developed? It happens in a number of stages. One is concept study. Any new product development starts with a concept. Concept is on the paper, like you see the reactions even in the textbooks and all. Okay, the concept is about conceptualizing the raw material to product. Okay, it gives broadly the technically this product can be manufactured from these raw materials, and the properties of these things will be like this. What are the various steps involved in converting the raw material, like a block flow diagram. Okay, so then next stage is feasibility study. So you all have to understand one thing, that technically viable product also should be commercially viable, because any company investing money in establishing a big processing facility, they have to sell the product and make money, correct? Otherwise, there is no use of spending money. So they would like to see the commercial viability of the process. So the feasibility study is carried out by, there are companies who are specializing in conducting feasibility studies. They study the technical feasibility, and also they have tried to see whether one route is possible or more process routes are possible to obtain the products from the same raw material, starting material. That then they conclude the technical feasibility. The second part is you have to do some preliminary design and do some sizing of the major equipment, and also estimate the cost of the plant. Okay, then after establishing the cost of the plant for a particular capacity, then they will see what is the return on investment. Okay, how many years it takes. Immediately any plant will not give you profit. Initially 1 or 2 years or 3 years it will take to stabilize, and then you slowly sell the product and get the money back. So after a few years, maybe 2 years, 3 years, in large complexes, it may be even 5 years. After 5 years only, the owner will start seeing the profit. So this period is called the initial period. When it is just to start giving the profit, that point is called break-even point. And I hope you must have studied the economics part of the process engineering. So the feasibility study establishes the technical feasibility and commercial feasibility of the process. Once it is established feasibility, then it goes to the next stage called FEED. FWED. It should be written in capitals. So it is abbreviation of front-end engineering design. So there are companies which make the feed document from the feasibility study, and they develop much more details of the processing facility. All the major and minor equipments will be sized, and then more accurate cost estimates will be made in the feed, and some studies have to be made. The process, the feed will also carry out certain studies of the safety of the plant, and the various studies like flare, blow down, and the studies associated with the equipment, etc. So those things will be happening in the feed stage. Then feed is, with all these attributes, it becomes a basic engineering package. So up to this, it's a high end. The process engineering design development, these are all the high end studies. So highly experienced process engineers will be involved in developing these stage by stage studies. After that, the owner will float the basic engineering package. He will call for tenders, and major detail engineering companies will be estimating the total project cost, including the equipments and systems. Then they will submit their quotations. So there may be a number of companies competing for getting the project. So the owner will evaluate the quotations from various detail engineering companies and compare the uh, not only price, their capability, how capable they are in doing, and they will evaluate their past experience, their track record. Maybe they will talk to the companies where these companies have already worked. So all these things, evaluations will be done. Here also you have technical evaluation to see the capability of the engineering company. Then they will see the price. So if there are two or three parties technically competent, technically acceptable, then they see the price. Whichever company has quoted the lowest price, they will be given the job. That is called L1. In industrial terms, we call as L1, the lowest bidder. He will get the technically acceptable, and lowest bidder will be getting the project. Then they do the much more detailed design, minute. This will be a very micro level. These are all macro level. Here it will be in the micro level. Every piece of equipment. I would say in simple common man language, every bolt and nut will be developed and costed. Okay. Then once it is done, they will construct the plant and operate the plant, give the guarantee. They commission the plant, do the normal operation, and they establish the commercial production, establishing the guarantee. Usually 72 hours continuous producing the products of the desired quality. So that is called the guarantee run. Then the person hands over to the owner. The same flow diagram, feasibility study. From feasibility, it goes to feed stage. Feed itself can be floated as that is proposal, and after somebody wins, he will do the execution of the project. So now we see what are the process engineering design activities where the chemical engineers are involved. First one is process simulation. I think most of you have heard about the simulation, and I have seen in some colleges they have even got the simulation software. So process simulation is nothing but building the entire processing facility in the software environment. So this gives you the complete heat and mass balance across the plant, and also it gives the scheme, process flow scheme. So then it is developed into process flow diagram. Then the next stage is you have all the parameters, design parameters available from the simulation, like flow rates, pressures, temperatures, compositions, and the energy content of the streams, various streams. Then each equipment you will have these streams available. So you have to size the equipment like distillation columns, heat exchangers, pied heaters, separators, vessels, etc. Then a pipe is very, very important. You have a number of pieces of equipment in the process plant, you all know. All these equipment are connected by piping. So the piping is an important part. It can be compared to our blood vessels in our body. Okay, the blood is being circulated throughout in our body through arteries and veins of different sizes. Okay, it can be as small as lesser than the hair thickness also. So the same thing is done by the process plant piping in carrying the process fluids from equipment to equipment. So that is one important discipline. Then you have instruments. Any process needs measurement of the various parameters and control of the parameters. So the sizing of the equipment, piping, and you have to devise all the measuring instruments and control instruments. That is called the sizing of these things. Then from these, you know the sizes of the equipment, you know the piping requirements, you know the instruments for the process. We make the piping and instrumentation diagram, which is the detailed schematic. So every vent and drain wall, even half an inch size lines will be shown in the piping and instrumentation. It is a very detailed engineering drawing for the process plant. I would say this is like your horoscope. The plant's horoscope is the piping and instrumentation diagram. It goes all through the life of the plant. So whenever you do some changes in the plant, that should be incorporated in the piping and instrumentation diagram. Okay. This is a very, very important document. And this is the only process engineering document which goes for construction of the plant and commissioning and operation of the plant. So this is very important one. Then afterwards, we have to make data sheets for each and every piece of equipment. So whatever equipments I explained earlier, columns, vessels, exchangers, fire heaters, separators, pumps, compressors, etc. Okay, all the equipments, the process engineer makes equipment data sheets. And next is instrument data sheets. In the process, you all know there are 4 basic parameters: flow, pressure, temperature, level. Okay, of course, composition is the 5th one. The instrument data sheets we have to make for all the instruments, and we have to give the range of the parameters and what is the control to be affected through this instrumentation. So the control loops, instrumentation details are all explained in the piping and instrumentation diagram. So then process engineer makes certain lists. So you don't miss out any of the items. So you make the list of equipment. Whatever equipment comes in the process, you make a complete list of the equipment. I will show the details of these deliverables. Then line list, each and every piece of line piping connecting the individual equipments will be listed in a line list. Then package specification, certain things we don't do the design, mechanical design, we don't give sizes and all. Example, pumps. So for example, pumps, we say the pump should have the capacity of 100 meter cube per hour. And also it should develop a head of 100 meters. So that is the pump specification. And we will say the pump material of construction, depending upon the fluid it handles, we have to specify carbon steel or stainless steel, whatever may be the material. And finally, cause and effect diagram is nothing but the changes happening in the process. I will explain this in the subsequent slides. Cause is the change happening. Suppose you have a vessel with liquid, half-filled liquid. Okay, you have a level control in that. So something is feeding the liquid into the vessel. So from somewhere it is pumped into the vessel. From the vessel, after some changes, it is being pumped out. Okay, the level is being continuously measured on monitors. So what is the control you need here? There is a high and low limits for the liquid level in the vessel. So if the level goes high, what will happen? The vessel will overfill and it will lead to some catastrophe, some accidents. So when the instrument measures high level and it gives an alarm, then what is the next action? What is the cause for increase in level? Because the feed coming in may be more. So you close the inlet, comes back to normal. Then you can start allowing the inlet to this vessel. Similarly, the liquid is being pumped out from the vessel to some other use. So when it hits the low level in the vessel, you should not allow it go into the pump. So pump may get the gases or vapors. Your pump will cavity. So you have to stop the pump when the level goes to low. Until the level regains its normal, you won't operate the pump. So these are all some cause and effects. So the basic designs we develop is the design basis. So you all have studied the stoichiometry, correct? Heat and mass balance subject. So we always, any problem you are given, you always fix a basis. So you will say feed rate 100 moles per hour, like, and maybe you will assume certain pressure for the raw material, certain pressure material. These are all called design basis. So in large plants, the design basis is a very important document. It lists out all the required conditions, which is a compilation of the various parameters used in the process. So we fix the limitations, we fix the values for this. That is called the design basis. Then philosophies. What do you mean by philosophies? For any change to happen or any operation to happen, we keep certain parameters, certain critical values, and also we put some conditions, preconditions. This should be like this. The operation should be carried out in this manner, okay, like this. So we have various philosophies. One is called the operating and control philosophy. This tells you how to operate the required results from the process plant. Isolation philosophy is every piece of equipment should be isolatable. You understand what you mean by isolation? Isolation is when there is some problem in a particular equipment, you have to close the inlet and close the outlet. That means the equipment is isolated. Then you can attend to the problem in the vessel, rectify the problem, and then again line up the equipment in the process. So every equipment should be having isolation requirements. That is called isolation philosophy. This is mainly required for process upset conditions. Then blow down and depressurization philosophy. This is most importantly applicable for the hydrocarbon sector because we are handling very hazardous and flammable materials. Like you all know, crude oil and various products, gases, these are all highly inflammable and they may go to explosive limits if it is not controlled. Suppose some equipment is under fire, it is already designed for a particular pressure. If the fire is added, it is adding energy to the vessel, it will vaporize the contents in the vessel. It will increase the pressure in the vessel. The pressure will be increasing. Maybe a certain point of time, the vessel will break or explode. So to avoid that, we have safety features. When the pressure exceeds the safety limit, there are safety valves in the vessel. They will open and let the excess pressure go to the flare system. It will be safely burnt in the flare. Depressurization is when you take shutdown of a plant, you can depressurize and bring the plant to the atmospheric conditions before you do any maintenance. For that, we have depressurization devices in the plant. Drain and vent, these are very important. These are useful during the commissioning and preparing the plant for operation. You want to drain and clean the equipment. Similarly, you want to remove the gases from any equipment, you should have vent provisions. So drain and vent is very important for normal, during normal running it may not be required, but during startup and shutdown these are required. Safeguarding is there should be inbuilt safeguards in the process. Those devices we decide and incorporate in the design itself. These are all inbuilt safeguarding devices. This is spelled out in the safeguarding philosophy. Then you have to write a process description. Anybody to understand what is happening in the plant, what you are doing with the raw materials, what are the various stages in the process till you reach the final product. So that is called process description. And then after you do this process simulation, make a simulation report, make the heat and mass balance tables, then make different diagrams, process flow diagram, piping and instrumentation diagram. You all have to understand one thing, that any output from the design engineer is in the form of a drawing. Okay. So only drawings get converted into the actual equipment and plant. So one of our professor used to say drawing is the language of engineers. So here also you will see whatever design calculations we do finally ends up in the form of a drawing. So we put dimensions of the vessel, diameter, height, etc. Okay. So from the drawing only the equipment are fabricated. From the drawing only the plant is built using the various equipment and connecting pieces of pipes. And then various instrumentation and control systems are all coming from the drawing. So the drawings are very critical pieces of design documents. And various sizing calculation. Any calculation we do, pump hydraulics, line sizing, etc. These are all compiled into calculation reports. These are all kept for the reference of the operating people as well as the process engineers also. When we get a new project, your supervisor will say, or your lead engineer will say, go to the similar project we have done in the past. You read all those things, then you will get a good understanding of the design procedures and calculations. Then further to that, process engineer has to make a lot of lists, various lists. He has to fluid, because we are handling different fluids in the plant. So we have to make a fluid list. What are the various fluids we use in the plant and what are their properties? What are their boiling points? What are their flash points, etc. This is very important for the hydrocarbon sector, where we are using highly inflammable toxic materials. So this is used in establishing the safety of the plant. Okay, the safety engineer will take this data and he will design the safety systems. Equipment list I have already mentioned. Line list is all the lines you show in the piping and instrumentation diagram will be listed with their starting point, end point, what is the fluid handle, what is the operating pressure, what is the operating temperature, what are the design conditions, test conditions, etc. Tie-in list comes only when you build a plant adjacent to an existing plant. You are connecting an existing plant to the new plant. There are connections made between the two plants. Maybe some material is transferred from the existing plant to the new plant. So in those cases, we connect them. It is nothing but tying the old plant with the new plant. That is called tie-in list. Then data sheets we have already seen. Equipment, instruments, specialty items means in the pump you will be seeing the strainer, suction strainer, and we may inject some chemicals in the piping or equipment. They are called injection pills. Okay, such specialty items are also there. Specification for equipment which we are not doing the very detailed design, they are called the packages like compressors, pumps, fired heaters, etc. Cause and effect diagrams we have already seen. Description of process deliverables, basis of design I have already told. This is a very important key document. From the feed onwards it is getting developed. It will give a description of the facility, location, where the plant is coming up, who is the owner, and what are the inlet fluid composition, what are the raw materials coming in, if they are gas or liquid compositions, what is the flow rates, pressures, temperature, and physical properties of all the materials. And then what are the products we want to develop in this plant. So we have to give detailed product specifications and where the product has to be delivered. and what is the conditions of the product. Operating range, what is the turn up, turn down? Somebody has to mute their mic, I think. So the Venkatesh B, please mute your phone. Operating range is turn up, turn down. See, you have a capacity range. You will not run the plant at one particular capacity. If it is 10,000 barrels of oil per day, means you must be able to run it even at half the flow rate. That is called turn down. The plant should be designed for a range of capacities. Okay, if it is the design capacity is 10,000 barrels of oil per day, we usually design it for even half the capacity, 5,000 barrels of oil per day. And turn up is we slightly overdo the capacity. Usually 10% is done. I mean 10,000 barrels becomes 11,000. So the meaning is your plant should be capable of operating with the desired operating conditions and product qualities from 50% of the plant capacity to 110% of the plant capacity. Some people call it as flexibility. So design criteria for all equipment, we have certain design criteria. Those are spelled out in the basis of design. And life, usually we give 25 to 30 years for the operating life of the plant. That doesn't mean after 25 years we will close down and go. Many plants after design life also they live 30 years, 40 years till they become obsolete or the technology is obsolete. It can run, but minimum guaranteed design life for any plant should be 25 to 30 years. And then where are you getting the utilities like steam, cooling water, nitrogen, plant air, etc., where you are getting from them, whether you generate the utilities or you are getting the utilities from the existing plant nearby. Battery limit is where I start my work, where I end my work. This is very important. We have to have a clear understanding between the owner and the consultant. Okay, otherwise you will have problems. So owners usually they will try to put more work on you. So you have to be very carefully define your limits. Okay, this is where I start, this is where I end. That's all. Beyond this and beyond that, I don't have any responsibilities. Environmental conditions, the site where you have, whether it is a fertile land, you have to follow ecological norms, environmental pollution norms, or you are located in the desert like Gulf countries, all the oil and gas facilities are located in the desert. The deserts will see very high temperatures in summer, very low temperatures in winter. So you should have the complete meteorological data on the site conditions. That is called the environmental condition. The rainfall, wind speed, wind direction, okay, humidity, highest temperature, lowest temperature, whether there is any snowfall or any sandstorms. In deserts, you will have sandstorms. All these things will be spelled out in the environmental conditions. The process flow diagram is a very important flow diagram. It is a schematic drawing. It is one step more than the block flow diagram which I have shown. I will show a sample diagram, so no problem. So it is a schematic drawing of all the connected equipment and the complete scheme is shown with major controls. Okay, major equipment, all major equipment will be shown. All the interconnecting lines including the utilities will be shown, main control loops will be shown. The shutdown valves and emergency shutdown valves, these are all used during the operational upsets or startup shutdown of the time. Heat and mass balance will be shown. Any PFD should have a heat and mass balance. Every line on the, every interconnecting line on the PFD is given a number that is called stream number. So for each stream, there will be a table which gives the stream description, composition of the stream, its mass flow rate, molar flow rate, its density, viscosity, thermal conductivity, etc. All the physical properties. That is the heat and mass balance. So if we make a process flow diagram for a utility, for example, cooling water system, it is called UFD, utility flow diagram. So the diagram may not be very clear for you on the screen, but it shows a number of pieces of equipment which are interconnected. This is a typical oil and gas separator. The oil and gas stream collected from many wells are combined and brought to one big vessel. It is called a high pressure separator. Okay, here the gas is separated and balanced liquid is taken to the second vessel and some pressure let down across the level control is done. So when you reduce the pressure, what will happen? Some more dissolved gas from the liquid will be coming out. Similarly, you can have a third level separator also. So all the gases separated from this equipment are all connected, and then the gas stream is taken for further processing. Liquid stream is taken for refining, crude oil refining. The piping and instrumentation diagram is the very key document for any process plant. It is a very much detailed version of the PFD. You can understanding purpose, you can say piping and instrumentation diagram is the very much detailed version of the process flow diagram. Every bits and pieces of the plant is shown here. All the process lines, all the utility lines, all the equipment with installed spares. Suppose mostly pumps are spared. You know what do you mean by spare? Spare is an extra equipment. Pumps should not fail. If one pump fails, because of that you have to stop the plant, means it's a big production loss. So such a critical equipment we always put two. If I need one pump, I will put two pumps of equal capacity. So one pump will be online. If that pump creates any trouble, we isolate that pump and switch over to the spare pump. So the spare pump will take care of the process. The pump which is having trouble will be maintained and kept ready for any changeover. So this is called the spares. Okay. These are all coming as part of philosophy. Process philosophy will say spares philosophy. There is a spares philosophy. Okay. Don't think that all the equipment will be spared. Only pumps and exchangers may be spared, but not the big items like compressor and all. Compressors are very costly pieces of equipment, so nobody puts spares, but all the operational safety features will be inbuilt, and they are running, compressors are running years together without any problem. And what are the details shown in the piping and instrument diagram? It will show the line size. Every line size will be shown. What is the service? What is the fluid it is carrying? And any major plant will have number of units. For example, if you go to refinery, you will have a crude oil distillation. You will have vacuum distillation. You will have a fluid catalytic cracking unit. So different units are there. So each unit will be given a number. And then line sequence number. So one thing you have to understand in the process plant design, numbering philosophy is very, very important. So each and every piece in the plant is being numbered. It is like name given to us. Okay, we are all identified by our name. Similarly, all equipment and even lines in the plant are numbered and they are identified by the number. So numbering system is very, very key to the preparation of the P&ID. So we have unit number, you have line sequence number, and piping specification is nothing but material of construction. What is the material used for making the pipe? Maybe stainless steel or carbon steel. Okay. Insulation, whenever the pipe carries a hot or cold fluids, you have to put insulation so that the temperature is lost to the atmosphere. Also to protect the people working in the plant. Accidentally, if somebody touches the pipe carrying a hot fluid, you will get a burn. Okay. So to avoid this and to avoid energy losses, we insulate the lines. All the insulation type and thickness of the insulation will be given here. All the instruments, control loops, manual controls, alarms, trips, everything will be shown here. So other details are walls. What are all the different types of walls? You have gate wall. Most of you know gate walls, globe walls, ball walls, okay, check walls. All these things, different types of walls are used depending upon the process requirement. They all will be shown. heat tracing, if suppose some line is carrying some hot fluid which should not be cooled down, it may become a solid if the temperature falls down. So you heat the line, you use electrical heat tracing or steam heat tracing. And then insulation. Specification break is many times in the process, when the process change occurs, the material of construction may change. So you have to change the material spec, that is the specification break, from carbon steel to stainless steel. Wherever the change happens, we call it a spec break. Scope, we have to put battery limit. Suppose compressor means we will put a dotted box inside which we show the complete compressor is by a vendor, a supplier. So that is the scope of the vendor. So we put a scope identification. When the pipes will need slope sometimes, if it is a gravity flow, we have to give some slope. Specialty items, I already told, filters, injection devices, etc. So what are the inputs required to prepare P&ID? We need process flow diagram. We need legend sheets. I will show some legend sheets. And process philosophies, piping material specification, and material selection diagram. So what are the materials to be used for various pieces of equipment? Again, this shows P&ID. You can see PFD, we have shown 2-3 equipments together, but when it goes into much more detailed process piping and instrumentation diagram, we see one equipment. This is a large separator. It has an inlet. It has a gas outlet. There is a safety valve here. There are drain connections. So oil outlet, water outlet, and level controls. Okay, the level control on the other side. You have pressure controls. So much details are shown. So one PFD may split into number of P&IDs. That much you should understand. Equipment list, again, each and every equipment will be figuring in the list. And what are the details shown in the list is type of equipment, means heat exchanger or column or vessel. Number of equipment, if we have more than one, we have to say operating, one standby. Equipment dimensions, you have to show the diameter, length, etc. Operating pressure and temperature. Design pressure and temperature is something we always give a margin. The vessel will not be exactly designed for the operating pressure and temperature. We add some margin. If suppose we have 10 bar pressure operating, we will put at least 10 to 15% more. It should be about 12 bar design pressure. Temperature, we add 15 to 20 degrees. Okay. If it is 100 degree operating temperature, we put 115 degrees as temperature, or whatever maximum temperature the vessel will be seeing. Okay. During upset conditions or when you do steaming of the equipment, steam temperature is, if it is higher than the operating temperature, the steaming temperature should be the design temperature. Material of construction for that equipment. Power consumption, if it is a pump, you will say what is a kilowatt required for running the pump. Accordingly, motor will be selected by the electrical engineer. Weight information, usually for vessels, we have to give the empty and water filled. Okay. This is a typical equipment list. All parameters are listed like this. I am really not sure whether it is legible, but don't worry. Whatever parameters explained in the previous slide are put in a tabular form. This is the deliverable in the final form. Line list, similarly, it will list all the lines in the plant, and you will say line size, the fluid handled, pipe material specification, installation type thickness. Same every equipment, every piping will have the operating conditions, design conditions, and where the line starts, where the line ends. And if the line crosses through number of drawings, you will say connecting P&ID number. This line comes from this P&ID and passes through this P&ID. If it goes for number of P&IDs, we have to put OPC connection. This is called OPC connection. And all pieces of equipment and piping are always tested for a higher design pressure, more than design pressure. Usually piping is tested for 1.5 times the design pressure. And what is the testing medium? Usually we use water. Water is the test medium. It is called hydrostatic test. So typical line list, again, this may not be very legible, but whatever parameters explained in the previous slide, they are all listed here. Okay. All the list, you will find one last column, remarks. If you want to put any specific condition against any of this equipment or line, you have to write here. This line will have vibration. Suppose the line is connected to compressor, there will be mechanical vibrations. We have to write that this line is compressor discharge. So this will have uh, vibrations, etc. All specific things we have to put in the remarks column. Cause and effect diagram is the compilation of the process causes and resultant effects. Just now, some time back, I explained that for all the process operations, you will have this cause and effect. Example was high liquid level in the storage tank. This is the cause. What is the action? When it reaches the high level, alarm will be raised, operator will be alerted. He has to go and close the inlet valve. That is the effect. Similarly, if the liquid level in the vessel hits a low level, first level of this one will be alarm, low level alarm. Operator will be alerted. He will go and stop the pump. If operator is not acting, you may ask what will happen. So there are automatic trips. Okay, if operator misses the alarm, there will be next level of safety is automatic trips. Typical cause and effect diagram is like your X and Y diagram. All the causes are listed. All the causes are listed in the horizontal rows. The effect will be listed in the vertical rows. If this is the cause and this is the effect, the cross mark says for this cause, this is the effect. Suppose the low level means stop the pump. That is the action. So the cause and effect is configured like that. This is the format. Data sheet again gives more details about each and every equipment dimensions, orientation, horizontal vessel or vertical vessel, what is the fluid handled in the equipment, its composition, properties, pressure again operating, and design, temperature operating in design, nozzle size. All pipings are connected to the vessel, inlet nozzle, outlet nozzle. We have vent nozzles, drain nozzles, level instrument nozzles, temperature measurement connections. All those nozzles will be shown in the equipment drawing. So you have to make a sketch and show all the nozzles. Okay, then as usual, metal of construction for the different parts of the equipment. There were packages. You will say compressor means you will say this is the flow, inlet flow to the compressor. This is the inlet pressure, inlet temperature, composition, properties. And then what is the requirement at the outlet? The gas should be compressed to certain higher pressure. What are the guarantees to be given by the compressor vendor? Scope of supply, what the compressor supplier will give, what items we will be supplying. Okay, this is a scope definition. And what are the utilities required for the compressor package, that we have to tell the vendor, and he will tell you how much he requires. Instruments, we make instrument data sheets for flow, pressure, temperature, level, and analyzers. These are the important parameters, process design parameters. And input is again fluid properties we have to give, density, viscosity, etc. Okay, flow rate we have to give. For instruments we have to give a range. Okay, not one value. We have to say level means what is the minimum level, what is the minimum level, what is the normal level, what is the maximum level. Okay, pressure minimum, maximum, temperature minimum, maximum. Composition we have to give the various components in the fluid. Level settings, as I said earlier, low level means this is strip. Triple L, low liquid level, is alarm. This is a normal operating level. High level, HLL, is high liquid level. This is alarm point. High liquid level is the trip point. Okay. When the operator doesn't listen to the HLL, high liquid level alarm, then when it exceeds the HLL level, it goes and hits high liquid level, the equipment is tripped. Valves, we have to again pressure safety valves. We give capacity of the valve, operating and design pressure, set pressure. At what pressure the safety valve should open and release the excess pressure. Back pressure. These more details will come. Don't worry about that. Again, like any other piece of equipment or line, you have to have operating and design temperatures, drilling temperatures. Various cases may be there for the safety valve. And control valves, we have to give flow rate, inlet pressure. What is the pressure drop across the valve? and fluid properties. Now the important thing is, one thing I want to emphasize here, this is not a one-man army. Only process engineers cannot do the entire plant. You need the help of other discipline engineers. So I am just explaining what are the various disciplines involved in the process plant design. First and foremost is HSC engineers, okay, health, safety and environment. They design the safety features of the plant based on your documents. So we give them PFD, PNID, fluid list, etc. They do the safety design of the plant. Piping is another important discipline. They actually make the plant layout. Okay, we give the equipment list, we give the piping and instrumentation diagram. They make the layout, how the equipments are located, what is the distance between them, how they are connected, and how the pipes are routed between equipment to equipment. Then nowadays they have 3D models. These are all in the 3D environment. There are special software to make the 3D models. So it's really interesting to see the plant on the computer screen. So you can walk through the plant and see various equipment. Okay. Mechanical engineers are very important people. They do the equipment procurement. Based on our process data sheet, they make the mechanical design data sheet and send it to the vendor. They get the equipment details, equipment drawings, and the pump rotating equipment like pump, compressors, etc. They also design the HVAC, heating, ventilation, and air conditioning requirements for the plant facilities. Electrical engineer, we all know we have a lot of electrically driven equipment, motors will be there, and then your HVAC system is there. And all the instrumentation will be driven by 110 volt AC supply. So power supply is very important. Okay. So electrical engineers design the power systems, power distribution system, lighting, earthing, all equipment should be earthed. This is very, very important to avoid any mishappenings in the plant. So layouts they make, earthing layouts. Instrumentation and process control engineers, they design and procure the instrumentation and control systems based on our P&IDs and instrument data sheets. Okay, civil structural don't get data directly from the process engineer, but the mechanical, piping, electrical, instrumentation engineers give them the details. So mechanical engineer gives them the equipment weight, etc. They will design the foundations. And tall equipments, we need a structural support in able to reach. You need structural supports, staircases, etc. And then plant buildings, they design control rooms, office building, and then fencing of the entire plant, compound wall, security gate, okay, time office. So many things are there. All these are done by and then drain system. Most importantly, the drainage system of the plant. That is all done by civil structural. Telecommunications is a department which is responsible for establishing the communication system. So we have seen alarm system and all, how the alarms are heard. The telecommunication department provides the alarm equipments, okay, the hooter, etc. They give the annunciators, hooters, etc. So telecommunication is another key department. Just to quickly, I will go through the interface. For HSC, we give process flow diagram, heat and mass balance, P&ID, process data sheets. They use it for classifying the plant. The plant will be classified according to the hazardous nature of the fluids handled. The fluid list also should be added here. Then the HSC department runs the HACCP study. You all know HACCP. What is HACCP? Hazard and operability study. During design stage itself, when we have done about 30-40% of engineering is completed, the plant will be analyzed, P&ID by P&ID it will be analyzed, and any hazards are identified, we have to do some mitigation measures. We have to provide enough safety to avoid any hazards from happening. PFD, P&ID for fireproofing. Okay. Piping, we get they get a process flow diagram, utility flow diagram, P&ID, line list, equipment list. They develop the complete plot plan. It is called plot plan. which shows the location of various equipment and how they are connected by piping. Material takeoff is they estimate what is the quantity of piping, what is the material of construction for piping, bill of quantity, etc. From this, the cost of piping will be estimated. Then from the again same equipment list and all, they will do the routing. So one thing you have to remember, all the outputs from these departments will come back to process. Process engineer has to review and see that his requirements are met. So you should not sacrifice any of the process requirement for the convenience of the other disciplines. The process intent is very important. Similarly, instrumentation, we give mainly the process data for inline instruments, actuated valves, okay, and then P and ID, most importantly P and ID, okay, this piping and instrumentation diagram. Piping and instrumentation diagram is extensively used by piping and instrumentation department. From that we do control valve sizing, but the instrumentation department finalizes from the vendor. Okay, logic diagram. So when the plant will go to shut down, under what conditions, we give them the control philosophy, cause and effect diagram, ESD philosophy, emergency shutdown. Any fire happens means it is an emergency. So under emergency conditions, how the plant will be shut down. These are all given by process. Then these people will make the ESD logic diagram. Then control narrative, how the operation should be controlled, what are the various parameters to be controlled, what are the ranges of them, and the alarm and trip set points, all those things we give. They do the functional analysis. P and ID is used for instrument index and designing of the control system. Electrical, we give them the electrical load list, all the electrical driven equipment. Pumps, you know, you must have studied in the theory also. Once you know the head of the pump and capacity of the pump, there is a formula to calculate the brake horsepower using the pump efficiency. Okay, so we estimate the electrical load for the pumps and electrically driven equipment. That electrical load list is given to electrical. They will add some more margin. They will decide the type of motor, size of the motor, etc. And similarly, when there is any heat racing, I mentioned earlier, when we may have to maintain the temperature in a particular process line, and we tell them use electrical tracing. If we say electrical tracing, they will design the electrical tracing requirement, electrical tracing system they will do. From the equipment list, electrical load list, they will make the preliminary load list. They will make the single line diagrams for the power distribution. Okay. Mechanical, we give them data sheet for equipment and packages. They make the mechanical data sheets. They make the request for quotation, send it to the vendor, get the vendor offers, all the procurement activities they take. And one important thing we have to remember as process engineers, all the vendor items, whether it is pump or compressor or any equipment coming from the third party, we have to review all the offers and see that the vendor has taken care of all the process requirements. So it is the duty of the process engineer not just design the plant and issue the data sheets, deliverables, drawings, but also you have to get the output from the other related departments, review them and see that all the process requirements are addressed and taken care. Okay. So again, they also make bill of quantity, etc. So I think I have taken almost 1.5 hours. Okay, 1 hour and 15 minutes. I hope the material was useful to you. At least it has introduced you to the process engineering design subjects. Now maybe you can raise your questions. And if somebody can read the questions, I will answer. Swishti madam, who is collecting the questions?
Yes, sir. Okay. I'm there, sir. Thank you so much, sir, for this elaborated session of process design. Definitely, I think the final year students of chemical engineering, what they read in the book, it's totally different, because always I think books will not give the experiences from the industry. So you have shared a complete, I think, from the scratch to building a plant. So definitely, I think when these engineers joined in any industry, definitely they will think about you. So as how you have taught them, including piping or ASOP or safety or scratch level of a design. So thank you so much. I think it's open for QA session.
So if they want, I can share the material also if they require.
Yes, sir.
So I can send it to you. Maybe you can distribute to them. Yeah.
Yes. Our intern can, you can even unmute yourself. You can ask question or you can even put it in the chat box.
Any questions, audience? Maybe subject is too heavy for you.
May not be.
Anyway, it is very important. This presentation shows you the conversion of textbook knowledge into the industrial practice. In simple terms, I would say, this is how the theory and principles we study. You have to remember all your theories are valid, all principles are valid. They are taken forward in designing the process plan. Only the application means are little different. Maybe it's not possible to give everything in the textbook. So textbooks guide you through the principles and processes, and how it is actually achieved in the real life scenario is what I have explained so far. So you can raise your questions if you want to raise now.
Intern, I think there is an opportunity for you all. Maybe we are going to select some 3 best intern also in this internship. So whoever is asking and attending, there is a criteria has been kept out. So whoever has been asking more queries and enhancing your knowledge, and even you can give a challenge to speaker also, so that they will come back in getting some more detailed answer also. Maybe you're all final years, so definitely I think you're all going for interview. I think you need to open up. You need to open up and you need to have a good interactions. Otherwise, going and sitting in front of any interview, it's going to be very tough. So
my sincere advice is don't hesitate to ask questions. Don't think that the question may be silly and all. There is nothing like that. At any age, at any stage, you can ask questions. If I have, for example, the latest electronics, phone systems and all, I am not very comfortable sometimes. I go to my children, okay, I go to my friends who are more knowledgeable, correct? So don't hesitate to ask questions, whatever may be the questions. That's how, even if you join a company or an industry, initial few years you have to keep your ears and eyes wide open, look around and listen to what is happening, and also always ask questions. If somebody says do this, do that, means just don't do that and keep quiet. You try to know the reason. If your boss says, okay, keep 25 mm margin here, means what is the basis for the 25 mm margin? Okay, you can ask. That is how we will know. For every calculation we do in the industry, there is a basis. Okay, there are assumptions. So those things get clarified when you only ask questions. Okay, somebody has raised the hand.
yes, sir. Arun has asked. Sometimes our process equipment or process plan got failed, or any failures happened even when we follow all of these conditions and descriptions. If yes, please describe it, sir.
With all the safety devices inbuilt in the design, actually these are all operated by human beings. You know, there are human errors sometimes. Okay, the human errors, that is why the HACCP study is done. I was telling you about the hazard and operability analysis. The complete plant is analyzed, taking P&ID by P&ID. Every equipment is analyzed. If you have a distillation column, it is taken, and all the incoming streams to the equipment, all the outgoing streams to the equipment, and pressure safety valves mounted on the equipment. Okay, level controls, pressure controls, all these things are in place. So now somebody will ask in the HACCP, what will happen if the feed flow rate increases? What will happen if the reboiler temperature increases or decreases? What will happen if the cooling water fails in the condenser? Okay, these are all the typical questions raised during the HACCP session. It is possible in the real life scenario, cooling water may fail. There may be some problem in the cooling tower. Okay, so there are system dependent problems. Some are man-made problems. Okay, if the operator doesn't keep track of the parameters happening, any problems happening, that leads to a accident and some leakages. Okay, after all, the plant is made of a number of pieces of equipment and interconnecting piping. Most joints in the piping will be welded, but when the pipe is connecting to an equipment, you cannot weld because you want to isolate the equipment, correct? You want to remove the piping and make the vessel isolated, means there will be a flanged joint. You understand what is flange joint, correct? Two faces, flange faces will be there. They are bolted together with a gasket in between. Gasket is arresting the leakage. Okay, if the gasket fails or gasket is torn off due to service life, then there may be gas leakage or liquid leakage. So such leakages, if it is not seen and attended to by the operating engineers as well as safety engineers, it will lead to a catastrophe. Or sometimes due to overpressure, pipe may burst. There are industrial accidents. A lot of accidents happened in the industry. I think there are books written on industrial accidents. If you go to internet, you will find a good amount of accident history. And fortunately or unfortunately, the accidents also lead to the safety in design. By looking into the accident, why it happened, how it happened, they all do the analysis. They find out the problems in the design. They improve the design based on the accident history. Uh, they make the improved design. Accidents in a way helped, and because of accidents, whatever safety provisions we have today are all possible. So it is
Okay,
interesting.
sir. Thank you.
Nowadays, the advantage you have is internet is having a wealth of information. If you go and type industrial accidents, you will get a big list of accident history.
Yes.
So you are right. In spite of all these inbuilt safety provisions, accidents do happen. Now, recently in Visakhapatnam, you all heard the styrene leakage, correct? It had some casualties and many people got affected. Correct. Bhopal, in India, the biggest ever tragedy is the Bhopal gas release. The deadly methyl isocyanate leaked during the middle of the night, and many people were sleeping. So, and this is a heavy gas. This goes and settles. Okay, this is the property. The property of the gas comes here. Okay. So the deadly gas leaked and it was spreading along the ground, and many people got killed during sleep itself. So the property helps. Even LPG is heavier than air. You all know that, correct? That's why if you smell leakage in the kitchen, better be careful. Don't operate any electrical switches. Keep the windows and doors wide open. Allow the air to flow so that it will sweep away the leakage, and then try to close the cylinder. Okay. So these are all the safety starts from home itself.
Yes, sir.
Yes.
Thank you so much. I think there are a few more questions are pouring inside. One, Mr. Chandrasekharan. So I think he's clubbed two questions. Um, okay. Does the company have a separate this data sheets uh, in the department to take care of such records? If so, will be assigned for such designation or directly as operational managing team?
No, any design company has standard formats. First of all the discipline, not only process engineers, I listed the whole lot of design departments: process, mechanical, electrical, instrumentation, piping, telecommunication. All departments, they have their standard formats to make the some of the formats I showed you may not be very legible in the screen. There are standard formats. Any standard engineering company has standard formats. You don't need to develop anything. It's already there. And that is a company standard. Okay, each company has its own standards. All these standards are available. The quality, one more important thing I wanted to tell you is there is a quality department in all the companies. The quality department maintains the standard formats, procedures, and checking of the deliverables. Don't think that you are joining as a junior engineer, you prepare a data sheet, it's not released to the other discipline immediately. Your calculations, your data sheets will be reviewed by your immediate senior. and then there will be a lead engineer. There are two levels of checking, at least two levels of checking to make sure that the design, whatever we are issuing to the other discipline or to the client, is perfect. No mistakes are allowed because mistakes may be very costly. Okay? So there are multi-level checking of the documents. So there is a quality department which has laid out rules for maintaining the quality of design and documentation.
Thank you, sir. I think from another question from Muthumayal.
Hmm.
Sir, do design companies at Chennai hire freshers? What are all the subjects in chemical engineering where we should have strong knowledge to get a job in design concern? And what kind of extra skill acquiring courses need to be learned by a freshers to have a job at the design firm?
Generally, the interviewers, all the first question, all companies definitely recruit freshers. Most companies, I have worked in most of the major companies in Chennai, Petrofac, Faster Wheeler, Saipam. Okay, these companies they go to campus. So campus interview, they have select universities or colleges in their list. They tell the HR department will be doing this activity in the company. They will contact the educational institutions and tell the department head or the principal to keep the students ready. They will give some minimum requirements. Students should have scored minimum, say, 70%, 80% marks, and should not have failed in any of the subjects during the course. It means no arrears. All these things, conditions, the HR will tell, and then the department head will keep the students ready. And then the team goes to HR. One HR person will be there and one discipline. If it is a process department, a senior most person will go along with the HR person. And mostly we try to test only your understanding, physical, the understanding. Not no, we don't ask you to do any calculation and all. We just want to say, see what because you are fresh from college. We assume that you are in touch with your subjects and you don't forget. Means you are just coming out of college, so you should remember. If somebody asks what is Dietz-Boelter equation in heat transfer, you must be able to tell what is Nusselt number, what is the significance. These things, this kind of questions. If I go, I used to ask very simple questions. What the interviewer looks for is your how you project yourself, how confident you are. Okay, if something you don't know, don't worry. There is nothing wrong in saying no, sir. I don't know. There's nothing wrong. Out of 10 questions, if you are not able to answer 2 questions, 3 questions, nobody cares. The way you project. Okay. And another thing is at the end, usually I ask the candidates, do you have any question about the company or about the future in the company? What is the career prospects? All those things you can ask. There is nothing wrong. And another important thing I am telling you is any company you applied and they have selected you for interview, you go to the website of the company, read about the company. You will get all the details of the company. What is the company? Where is it headquartered? Whether it is an Indian company or a foreign company having Indian branch. What are their functions? What do they do? What is their line of action? What kind of plants they design? All those things. Okay, some companies specialize in oil and gas. Some companies specialize in refinery. Some may be in petrochemicals. Okay, some companies may be fertilizer. So if you know their line of activity, it is easy for you. Okay, and also their questions may be from those type of industries only. Okay. Uh, when I went to Engineers India interview, I was working in a fertilizer plant. I have gone through the ammonia plant operations, and finally for 6 months I was in the urea plant operation. But the questions asked were mostly from the ammonia process, ammonia synthesis. Okay. What is the equilibrium conditions? What is the pressure effect? What is the temperature effect? You all know. Okay. So N2 plus 3H2 gives 2NH3, irreversible reaction, exothermic reaction. Okay, that means 3 moles give you 2 moles. That means if you increase the pressure, what will happen? It will go in the forward direction. If you keep removing the heat, it's an exothermic reaction. The reaction will go in the forward direction. This is called the equilibrium conditions, and the basic principle is what? Any system in equilibrium, if you disturb the equilibrium of the system, it will try to readjust itself to come back to the equilibrium situation. Okay, this is the basic thing, underlying thing in the ammonia synthesis. So like that, interviewer may ask questions in their own way. Okay. But the most important thing is understand the question. If you are not clear about the question, you may ask the interviewer, sir, may I know the question, please? I am not very clear. So that is how. And dress properly, go with a decent dress, and keep all your papers, documents, some extra copies you keep. If they want, you can hand over them. Okay. So these are all the interview tips. That is again a separate subject. But mostly they try to test your understanding of the basic principles. Sometimes they may ask, what is your interesting subject? If you say heat transfer, maybe the person will start asking questions from heat transfer. Okay. That is how it goes. Okay.
Yes, sir. I think there are a few more questions are pouring inside, sir. So we can go with the next question. I think it's maybe I think it's from Mohammadin Marzo. Okay, he's asking, currently I'm studying second year chemical engineering, sir. Can you say how to apply implant training and the methodology?
It is mostly your college must have some contacts with the engineering industries. Okay. So when I was working in Petrofag, I used to take the graduates after taking. This is after taking, but in the college, if you ask, your college should have some contacts with the industries, or your college, the person who is in charge of the recruitment, what is it? Placement, not recruitment, placement. Placement officer is, along with the institutional head, should establish contacts with the industries, and they normally allow. Okay, when we studied, we have been sent to different companies. Like Naval Lignite Corporation was very close to Annamalai University, so I was sent to NLC. We opted for NLC. I was in the Naval Lignite Corporation fertilizer plant for 1 month. That is a summer training between the pre-final year and final year. In the summer time, we went there. So the institution to take initiative, or maybe Google, if they approaches, we may have to, if possible, we may have to try to help them. If
Yeah,
possible.
definitely. Yes. Maybe after all COVID is over, we can plan it next year or after 22 also, I think.
And for your information, IICH Chennai Regional Center is conducting internship programs. As part of the internship program, apart from the technical experts lectures and all, the plant visit is also organized. I think last winter, our Secretary Gokul, he has taken the students to ISRO, Sriharikota, which is a very rare opportunity. Okay. For safety reasons and security reasons, many companies don't allow, especially ISRO, rocket launching place. Normally, nobody is allowed. Nowadays, they started allowing even public with prior intimation and permission. So we can organize as part of the internship programs.
Yes, sir. Okay, maybe I think the same questions was asked by Shivakumar also. I think you have answered. He said like how to join design industry and what are the preparations users for attend industry interview. I think you have answered it before itself.
Yeah, that's it.
Yes, sir. Maybe from Babin, apart from design, I am having huge interest in pharmaceutical studies. After finishing my 4th year, what step I have to take? So because you are so much experienced, sir.
Pharmaceutical industry is a separate line. Okay, the chemical engineers thing is, once you select a particular line, you will be proceeding in that line only, and it is not possible to change over. If I work in a refinery, I cannot go to a cement plant or sugar plant, etc. Because these are all unique processes. So if you are more interested in pharmaceutical industries, better you target such industries. Also try to gain more knowledge. I don't know whether there are any PG courses or diploma courses in pharmaceutical industries. If such courses are available, better you do one more course and qualify yourself for that. That's better. In the beginning itself, we are very sure that you want to become a pharmaceutical person, then better go with that and try to access the websites of pharmaceutical companies and find out what are their programs. Okay, you can even apply directly to them. There is nothing wrong. It's not necessary that you should qualify and then go. Not necessary. You can directly apply to those companies. If possible, you qualify. That will be another added qualification. So additional qualifications always help. If you have some experience in process simulation, let us say, then that helps. Very understanding of the process. Some colleges have process simulation programs like HISIS. I think Venkateswara College has. Many colleges have, and the student version of these softwares are very, very cheap. So whenever I go to any college, I always tell the department heads and principals to buy such software and give some exposure to the engineers. The supplier of the software himself will come and train the faculty as well as students to start with. Then you can manage and maintain the training. So that is good. I think you select your industry and you work towards that.
Yes, sir. I think there is another questions from both the Priyan and Divalakshmi. Is there any certified courses available regarding process design? Like same thing, what sort of software is best and easy in process designing?
Process design is a vast subject. As such, there are no defined courses for this. Because you have to go join the company and learn. Another thing I want to tell you, you cannot become an expert of all the fields I have explained. A process simulation. For example, in my department, I had 4 or 5 engineers who were totally involved in process simulation. There are engineers who are more oriented towards piping and instrumentation diagram preparation. There are engineers who specialize in safety valve sizing, flare system design. So within the department itself, they branch out, and we try to give exposure to them. So you don't need to worry about all the software. I told the process simulation, which is easily available, but most of the programs are in-house in many companies. Line sizing, how to size the lines carrying liquid, vapor, or two-phase flow. Okay. Similarly, pump hydraulics. These are all Excel spreadsheets are there. Every company, they have their in-house calculation programs, which are mostly Excel based. So you will learn. They will definitely, once you join, if you get the opportunity to join the design engineering company, you will be given. You will start with such simple calculations like line sizing, pump calculations, and the preparation of P&IDs, etc. Then preparation of data sheets, etc. So for all these things, they have in-house software. So you don't need to worry, and there are no external courses available to give training on this. Simulation may be there. I'm not sure. Gokul, there are some companies which give short-term courses on process simulation. I think it is there.
Regarding Aspen Plus and Aspen ISIS, I think some companies are giving up.
Companies are giving.
I will share it to those people. I think we in the first webinar we organized the Aspen Plus from Xplock Technology. Maybe they are interested, and the few of the students have already like last year also some people have joined in that course from Venkateswara, Hindustan also. Maybe I will share it to these people. They can also for it if they are interested.
What is the duration? 1 week or 1 month? What is
60 hours, sir. 60 hours.
60 hours. Okay.
It's only a fundamental of Aspen.
Aspen, how to know the features of any software program. You should know what are the various features available and how to go in a sequence, and how to, sometimes you have to manipulate the calculations. It's not that the software gives you whatever you want. Okay, you feed something, it gives you something. So you should be able to analyze the output and see whether it is suitable to your requirement. Otherwise, you have to fine tune the inputs. This is how the experience comes, and you will be definitely working under experienced engineers. They will definitely teach you and guide you. Yeah, next
Yes,
question.
next one from Magesh. Small human error leads to the large industrial accident because of lack of proper training. How long it will take time for freshers to become a professional engineer?
So normally most companies offer 1 year training course. In the 1 year, first 6 months will be mostly they give training on each and every design activity and give you sample works. You are not allowed in the project directly. So after spending 6 months to understand the discipline activities and how things are done, what are the various software and all, and then slowly next 6 months onwards, you will be inducted into some project. You will be given works, the small works to start with, and slowly you will get into the workforce. This is how. Nobody will put you directly. Even if you join a plant, you will be a training person, operator trainee for at least a year to understand. Okay, so they won't allow you to do anything. Control room, the freshers or fresh operator trainees will not be allowed to touch the instrumentation control. You have to stand by the side of the operators, senior operators, and see what they are doing. Try to understand, ask questions, and slowly they will allow you to do small things. It takes few years to merge into the mainstream. Yeah.
Yes, sir. There is a question from Abdul Rahman. Is it safety to keep the instrumentation signal device to give signal if the liquid flow behind the limit in the fluid, or mankind is the best way to turn off the flow problem?
He's trying to know about the fluid flow problem or level problem.
I think he's asking whether manually operating certain things is okay, or like maybe Abdul
Instrumentation.
Rahman, you can even open and you can ask, like you can mute and you can ask also.
Abdul Rahman, instrumentation has two options. One is putting it on manual and then putting it on auto. Okay. When you start the plant will be slowly ramped up to the capacity. If it is 1,000 tons per day plant, means it will not operate immediately 2,000 tons. They may start ramping up. Okay. Maybe it slowly starts with 100 tons, and then increase to 200 tons. In steps, they increase. So especially when you are operating below the turn down capacity, I told you 50% is usually turn down. Okay, the instruments and control system will be more effective when they are in the operating range of the plant, 50% to 100%. Below 50%, usually during startup or shutdown times, when you go down on capacity, they will put it on manual, and manually they control, they throttle the valves. Okay, they do the manual operation. Once it reaches the controllability range, it is called controllability range, then they put it on auto. Correct? It's like something like driving a car. Okay, you don't hit 100 kilometer per hour immediately. Correct? You start slowly, give acceleration, first gear, second gear, third gear, like that. Slowly increase. Okay. In automatic cars, they do automatically all this gear changing, etc. Okay. There are cars. They are trying to find invent cars without a driver. Means it will go on a specified route and all. It will do a lot of things automatically. In the plant also, there are options to put the control on auto mode or manual mode, depending upon the requirement. But during manual mode, one should be very careful because there is no automatic action. You are right. If somebody does a mistake during manual operation, it may lead to some incidents. That is called controllability range. Okay, okay then.
Okay, sir. I think Subishka has asked, I think you have already answered. She has asked, what are the courses that is available for process engineering and what can avail job opportunities? I think you have briefed this
You
same
briefed
question.
already. There are no specific courses for process engineering design.
Yeah.
Because these are all tailor-made things. We have seen whatever documents, deliverables I have listed and shown. These are all specific to each company, and there are no courses done by any institute or something like that. If at all, maybe we have to start such courses. Otherwise, the companies will train. Companies will select you based on your merit and interview performance. Once you enter the company, you will get the complete exposure to all the design activities. Yeah.
Okay. Maybe okay. We have one like from Akshay Kumar. What are the major problem you faced in this field, sir?
Major problem.
Maybe I think
Don't
in the
don't
field of
don't look into
design.
anything as problem. Major problem means you take it as a challenge. You say I started with a production company only first of all. So after doing my post graduation, I joined a fertilizer company. I was put in the operation. So the operation, the real people running the plant are all operators. They are not engineers. They are mostly BSc chemistry, MSc chemistry, etc. And generally their attitude will be they are not very helpful or conducive to the freshers, especially engineers, because after a few years of training you will go above them. You will become a shift engineer. He will be a junior operator, senior operator. By the time he reaches that level, he would have spent 10 15 years. So that was the situation. Now I don't know, it used to be like that. There will be always a cold war between the operators and the shift engineers. So initially you may not get any cooperation, but you have to be friendly with them and see the ways and means to come into their good books and gain the knowledge. That's it. They take it as a challenge. And design companies, I don't see any such problem. Only operating companies, this kind of problem will be there. Design companies were always under the control of your seniors, and mostly we guide, we help. There is nothing like ragging. There is no ragging in the industries, so you don't need to worry. So go with confidence and interact with your seniors and try to ask questions and understand things. That is how it goes.
Yeah. So I think we are completing, I think, with the QA session. I think lots of, even after that also it's pouring. So that I asked intern to initiate your QA whenever the session's completed. I think initially we were waited and now you are pouring up. So that's always like our
One
chemical
thing I
engineers.
forgot to tell, usually in the beginning of the session, I used to tell the people, please keep noting down your doubts then and there, so that at the end you may be forgetting. You may forget and then try to scratch your head, what was the doubt? So keep a pad and a pen or pencil handy and keep noting down your doubts. Then you can ask, it is easy. You can even post it. Then and there you can post in the chat box. That is easy. You won't forget the questions. But
Yes, sir.
nevertheless, how many questions will be there?
We have two more, I think.
Ah.
One is from Tamil Selvan. Sir, if any problem occurs in the automatic safety measure, while there is no human next to that, is there any other safety?
Actually, the plant has two layers. One is called the process control. My next session is on process control. I will explain more in that. But briefly, there are two independent layers in the plant. One is called basic process control system, BPCS. This is the system which is running the plant. This is always online, continuously monitoring the process, controlling the parameters and raising alarms or shutdown, all those things. There is another independent layer which is called the safety layer. That is called the ESD system, emergency shutdown system. This is like a watchdog. It keeps looking the process and looks for any leakages, uh, any untoward instance happening, okay, liquid spills, whatever it is. There are detectors. Even in the buildings nowadays, you have fire detectors, smoke detectors, etc. These detectors are always online. They will look for any such incidents, and they are all, there is no human intervention there. Smoke detectors or fire detectors, they are always online, and once they detect, they send the signal to the emergency shutdown system. Depending upon that, either you get alarms, or if there is a fire already, it may activate the sprinkler system, okay, spray system. It sounds alarm, a big alarm will come, really ear bursting alarm will come in case of a fire accident. Then the fire tenders will come, and they will start doing the active firefighting. That is, they will bring the fire water from the hose stations, from the hydrants, and they will fight the fire. So safety layer is independent, and it is not a human intervention. It is leading to actions. It keeps watching the process. Any untoward things happening, leakage, bursting, fire, it will detect and immediately raise the alarm. And in some cases, if it is equipment, it will pour water. There are sprinkler systems, spray systems. If the equipment is on fire, the automatic system will open the deluge wall, and lot of water will be poured on the equipment. So two systems are there in the plant.
Okay, sir. There's the last question from Mutumiyal. Sir, if the companies need experienced candidate, what is the best choice for freshers to start their career such that they can end up in a design job?
This is a $1,000,000 question. This is like whether egg is first or chicken first. Okay, it is something like that. Freshers definitely are required, because every industry needs to replenish their staff. Correct? Some people will retire. When they retire, you cannot go and search for manpower. So they keep adding. Most companies do this on an annual basis. They select people. But the thing is, there are so many colleges now. The output is very high, but the requirement is not that high. Okay, in the last company I worked, we used to take 2, 3, or maximum 4 process engineers, 4 process engineers in a year. So that is why the competition is more, and keep trying. And one more thing I want to tell: when you want to compete for the public sector jobs, okay, whether it is Indian Oil Corporation or ONGC, Oil and Natural Gas Corporation, or BHEL, whatever it may be, all public sector companies, they take people who have completed their GATE exam. Correct? So please prepare. If you are in the final year, please prepare for the GATE exam and try to pass the GATE exam. That is a prerequisite for applying to the public sector companies. So if you are not aware of this, please do that. Prepare for the GATE and pass the GATE exam. And then you can apply for the public sector. The public sector companies will take in large numbers, because they have a nationwide operation. Indian Oil Corporation has, I think, 12 or 13, whatever, maybe 12 to 15 refineries. ONGC has operation all over India. Okay. So those companies will recruit in large numbers, but the prerequisite is you have to be a GATE qualifier. Yes, Gopal, any more questions?
Yes, sir. Okay, that's all I think, sir. Maybe
Okay.
there's no further
Thank you so
more
much.
questions.
Thank you for your patient hearing, and I think the strength maintained. Even now it is 78. I'm really thankful to the students for their patience hearing, and you can keep contacting us through Mr. Gokul for any help. And we'll meet in the next session. Maybe in the next session, I will share my phone number and email ID. Okay?
Yes, sir.
That will help them.
Yeah, we have
I thank the IEA organizers, IEA, the 5 engineering colleges, their management and the staff, and most importantly, Mr. Gokul for organizing this wonderful series of lecture sessions. Thank you all. We will meet in the next session. It is on Wednesday, correct? Yeah.
Yes, sir. Wednesday, sir.
Wednesday. Okay. See you all on Wednesday. Thank you and
Yes, sir.
best wishes.
Thank you so much, sir. Thank you.
Thank you.
Yes.
Thank you, Subhashi, madam.
Thank you, sir.
Okay, sir. I'll end up the session.